Make sure your calculator's in degree mode. So look up here at the top if you have a newer calculator, it should say degrees. If you do not have a newer calculator, it's okay. Just hit the mode button, which is what you would need to do to change it anyway. Add degree should be highlighted around it with the box. Yes, honey. I don't know how to do it for the Casio, but YouTube will fix everything. This is what I've learned. Um, I don't know. I think I told you guys that we're restoring an old, okay, restoring is not the word. We're sort of making drivable a super horrible, terrible old car that we purchased. And YouTube taught us how to like, right now we're working on sanding around like the rusty edges to let like the paint come through and then like wipe it with the like clear coat. It's gonna be good. We actually drove it to Lucky this weekend and like didn't get stranded. It's a big deal. Anyway, okay. Are you guys in degrees?
Yeah.
Okay. Anyway, all right. So first, mark the angle that you're given, which is 67 in this problem. Okay, and then hypotenuse is 20 and x is adjacent. So this would be cosine. Cosine 67 degrees equals x over 20. And multiply both sides by 20. Times cosine. Oh no, I did the power. 20 times cosine 67. 7.8 equals x. Okay, any questions about number one? Okay. Excellent. All right, now they already marked the angle for you. So I'm going to put a theta there because I need a variable to use. And 17, is this cosine again? 17 is the hypotenuse. 7 is the adjacent. Oh, sorry. I like to do two different types on one day just in case somebody's absent, then they could get a review of it. I'm weird. Anyway, cosine theta equals 7/17. Okay, and then how do we undo cosine? It's called cosine inverse. 7/17. Okay, so this time on your calculator, you have to hit second cosine and then 7 divided by 17 in parentheses. Theta equals 65.7 degrees. Okay, everybody good? Okay. Now, I think you're done with your packet, except if you notice, tonight's homework is actually a worksheet in your packet. Um, so let's take a look at that. These 4 problems at the beginning are what we're doing today. So you probably don't know how to do those right now, and that's okay. Number 5 and 6 and 7 and 8 are all the trig that we just worked on. And then number 9 is a statistics problem. So why I'm telling you this is as soon as I'm done teaching, you should do the statistics problem if you don't have a graphing calculator at home, because you're going to need that for this. So you should start with that one and do that one in class. Does that make sense? Okay. All right. So Okay, so now I'm going to teach you how to do the first four on that worksheet. That's good. Me lucky.
Yeah.
That is the one that's in the. There's four. And then look, the Y you said he's three.
Wait, yeah, 60%. I think really bad. And if I was putting it in Aries and that will probably put me on a C plus.
Okay. All right, guys, here, let's go. This is all math to review, but I'm gonna pretend that you've never seen it before. This is called graphing or vertex form of a parabola. So either graphing or vertex form. I think Ms. Maselli says vertex form, but I think Mr. Guinan says graphing form. He says vertex form? Okay, I don't know. And who knows what Mr. Regalado does? That's supposed to be fun. He's funny. He's a funny dude. He's my friend across the hall. We like tease each other all the time. Okay, anyway. I've known him since he was like a kid. Okay, so we're gonna start with the easy one here, plus K. I'm gonna ask him. Hopefully he'll come in. And if you have a plus K, that is a shift up K units. And if you have a minus K, that's a shift down. Where did we already use that? We already used that this year in two things, actually, in chapter 1. I know you were here for it. Do you remember the rational function? How you'd have a plus something on the end and it would give you the horizontal asymptote? Yeah. Okay. And then the square root function, if there was one outside, it would move the endpoint. Okay, anyway, that's the easy one. Okay, now this. No, I can't live like that. Can't do it. I can't live like that. Can't do it. I had one arrow going up and one going down. Okay. X minus H is a shift right. And X plus H is a shift left. So X minus H is right. X plus H is left. Okay, now notice I left all of this space for A. So K is very easy. H is a little bit harder because you have to switch the sign in your mind. A, there's all kinds of stuff going on with A. A negative A means that it's a reflection across the x-axis. And you might think of it in math 2 terms like opens up, opens down, or smiley, frowny. Smiley, frowny. Okay, This is going to be a little challenging. I'll explain in a second. Hmm? I'll explain. I'll explain. Just give me a second. Okay, let me explain all this business. There's a lot of symbols and crazy stuff going on here. But it's not that bad. Okay, so A is the number in front. When I say the absolute value, I just mean ignore the sign of it. Because we already took care of the negative. The negative means reflection across the x-axis. Smiley frown, positive negative, positive negative. Okay, now ignoring that, what I mean by this is like, just look at the number. If the number is greater than 1, it makes it steeper. I want you to think of a parabola like a rubber band. Okay, so pretend that the vertex of the parabola is below my feet, and I'm holding the parabola in my hands, and I go like this. That would be vertically stretched, and it would be steeper. Does that make sense? Okay, so this would be like a 2, or a 3, or a 5, or a 10, or a 100, or something greater than 1. Okay, now in fancy language, what we say is vertically stretched by a factor of 5, vertically stretched by a factor of 3, vertically stretched by a factor of 10, whatever. So vertically stretched by this much. And in that too, you guys did dilations. And you took like a shape and you graphed it and then you made it like 2 times bigger. Those were vertically stretched by a factor of 2, because they were 2 times bigger. Remember doing dilations? Okay, that's the same thing. Okay, now, this notation right here just means that A is somewhere between 0 and 1, meaning it's a fraction or decimal. So it's less than 1, but not negative, because the negatives is the flip. So a fraction or decimal, that means it gets wider. And so I'm holding my parabola and I'm pushing it down, basically, it's getting wider. Like that's what it means. So vertically compressed by a factor of, okay, now, because the number in front is a fraction, you take the reciprocal of it. So what I mean by that is we would say, if this was a 1/2 in the front, we would say vertically compressed by a factor of 2. The flip. Because a factor is what you're multiplying by. So anyway, we're going to practice it. It's okay. All right, now I want you to look at this stuff on your page. You're looking at it, and we're going to make one more note here that's very important. So we're working with parabolas only. Now this actually it applies to a lot of different types of graphs, but we're going to start with parabolas because this is your best one. And I'm going to say, we're just going to establish together that y equals x squared is called the parent graph. The parent graph means the plain one. I'm the parent, I'm the plain person in the family. This means that, and all of my kids have different changes, transformations. So parent graph is just the regular old parabola without any transformations on it. Okay, what I want to do is, just to be super clear, I want to rewrite it into vertex form. And I want you to really think about why those two things are equal. Why was it legal for me to put all that stuff in there? Okay, because x minus 0 is just x, and x times 1 is just x, and plus 0 is just x. I didn't change it up in any way, shape, or form. I want you to think of those as basically placeholders, so you can really see the zeros and see the ones. Okay, but your parent graph in vertex form will have a 1 here because 1 times something is itself, and then a 0 here, and then a 0 here. Okay, so now, number 2. That was number 1. Number 2. You guys are going to use this. Look at this. I'm going to put up some graphs in Desmos, and together we are going to describe the transformations. Are you ready? It's going to be great. It's not going to be great. It's going to be great in about 2 seconds. It's going to be great as soon as I have the right thing on the screen. Okay. Now it's going to be great. Okay, so here's my parent graph. Everybody good? Everybody know what a parabola is? Everyone's seen a parabola before? This is your friend, the friendly neighborhood parabola. Here he is. Okay, now I want to prove to you that if I add in one as A, 0 as H, and 0 as K, that I did not change anything about Mr. Parabola, correct?
Yeah.
Okay, everybody good? Because that's going to be really important as we go through the chapter. Okay, now. Okay, now I made a new parabola. The original parabola is in red. New parabola is in blue. What are the transformations? Shift up 3. That would be a full credit answer for that. Shift up 3. Okay. All right, now I'm going to change it up. Okay, what are the transformations? Beautiful. Beautiful. Okay. Now, this one has 2 transformations. Shift right 1, shift down 2. Shift right 1, shift down 2. Now let me ask you a new question. What is the vertex? Mm-hmm. Okay, you're gonna need that. Okay, now. What are the transformations? Okay, how are we doing? You guys okay? Yep. All right, so let me be creative. Shift left 1, shift up 1.
See if we do them in order, like you do.
No. No. Okay, now here we go. I'm gonna throw a negative in the front.
No.
Okay, now that's not an incorrect statement, but if I ask you on a quiz or test, how to describe the transformations, I would expect three things, three little bullet points.
360 rotation.
Nope, I would say reflection across the x-axis,
Okay.
shift left one, shift up one. Reflection across the x-axis, shift left one, shift up one. You guys got it? Okay.
Oh my God.
Okay, this guy has 4 transformations. I would expect 4 bullet points. And I just start at the front. So, first bullet point, reflect across the x-axis, vertically stretched by a factor of 3.
What do you guys think?
It's tiny, but it's up there. There's a 3, I promise you. It's in front of them.
Oh, okay.
Okay, and then shift left one, shift up one. That would be a full credit answer. 4 bullet points.
Oh, I'm starting to understand the numbers.
Yay! Look, we're doing it. Okay. Okay, last one.
It's widened.
It's widened.
It's compressed.
Nice. Okay, compress.
No, that's not stretch. That's
Violet's available for transformations tutoring after school.
yeah.
So I'm on a quiz or test right now. I would go, okay, I see the negative reflection across the x-axis. So I see the fraction. Okay, now read your notes. Vertically compressed by a factor of, and what does it say? 1 over. 1 over. What's 1 over 1/3? Don't think it's just flip it. 3. Don't say negative 3.
Over.
The negative is taken from the
Okay.
negative. Okay. Slow down. First bullet point. Reflection across the x-axis. That takes care of the negative stuff. Okay, the 1/3. Vertically compressed by a factor of 3. So when I say 3, I mean reciprocal of 1/3.
That makes sense.
Then left one, shift up
And
one
if it was like 1 over 6, it would be like compressed by a factor.
of 6. And if it was, let's say, 2/3. Oh, Mrs. Talbot. Vertically compressed by a factor of 3 over 2.
Great.
Flip it.
Okay,
It's
yeah.
just the flip. It's just the flip.
Okay, I get it.
Okay.
I got it. This is great. What? If it's stretched, it's skinny. And it's not a fraction, it's a fraction. So, and you're like, it's good.
Okay, so these are the problems that are like the first 4 in your homework. And so go ahead and set this up. We're gonna do A together and then we're gonna do B in your groups. And we're gonna do this without a calculator. Yes.
That is so hard. I say so fun. I was like, yeah, I was I downloaded it. It's trash. It was so hard. It was literally so hard. But I play like Geometry Dash. And I've actually I put up this one the other day before I came. And I found out that's good. Yeah, honestly, like not have to like be. No, it was so bad. I was hanging at work and I was like, oh my God. I just keep failing, I keep dying, I keep destroying my towers. Like, and then like, and I hate that when they destroy your big tower, it's just like automatic fail. That's what I'm saying. It's like I made him like two like issues for that. Yeah, no, I downloaded Monsters like a while ago, and I got into it for a while, and then I just like wanted to like undownload my phone. And I was like, oh, great. No, I actually did like.
All right, you guys, let's do the first one together. No calculator. I'm just basically going to pretend that this is a quiz problem. So here I go. Shh. Foreshadowing. Okay. First thing I'm going to ask myself is, what is the vertex? No. Okay. So yes. So do you remember in chapter 1 how I told you to set this part equal to 0? Yeah. Okay. So this is B +5, -2. Also, you should know that this is a shift right because it's minus. So, okay. So the first thing I'm going to say down here is the vertex is 5, -2. Switch the sign. Don't switch the sign, basically. Okay. Now, I'm going to take that 5, -2 and put it in the middle of my table. And I'm going to go 6, 7, 4, 3. Okay, now mental math. 3 - 5 squared -2. Okay, so parentheses first. 3 - 5. -2. -2 times -2. 4. 4 - 2. Okay, mental math. 4 - 5. -1. -1 times itself. 1 - 2. Okay, and here's the beautiful part. If you do the setup this way, you can use symmetry to go back up the parabola with your previous answer. So remember, parabolas are symmetric. So if you put the vertex in the middle, you only have to do 2 pieces of mental math, not 4. We like you. Okay. So 2, 3, 5, -2. Okay, now the problem's not done. We state A, H, and K, and also describe the transformations. Okay, what is A in this problem? And if you're not sure, take a look here. What is it when there's nothing? No. What is it when there's nothing? Look up here. What? Okay. A being 1 is the usual. We don't have to write a transformation for that. It's just how they normally are. What is H in this one?
-5.
Nope.
2.
Nope. +5. Okay, look, remember it's minus in the formula. So H is the opposite sign. So if you want to, you can get it from your vertex. K is -2. And then that is a full credit answer. You have a table with 5 points. You've said the vertex, you've stated A, H, and K, and the transformations. Okay, now I want you guys to do B. You got it. As soon as you're done with B.
Yeah, it'd be a negative.
That's not true. Oh my God. It's so. No, it didn't. Hey, guys. I was just stretch fracture, yes. Wait, no, compress. But close. That's good.
Close enough for half credit.
Yes.
Some credit.
For for 3, did you get,
Like that. So, that means,
what do you get for
vortex
90?
I'm good at these, because I used to be really, really bad at these, and so it makes your nose like.
Give multiple.
Mm-hmm.
So now you just got the 5 plus 3 guys, which is negative 1. Square, which is 4 plus 1.
Right one, right?
Mm-hmm.
And then shift down.
Oh, actually, no. It's right 3,
Oh,
up 1.
yeah, I switched it then.
Yeah, and it's like negative 2 and then negative 5. Because of that.
What points did you plug in?
Shift down one.
I mean, just regular 2.
I just did this on it.
Regular 2, regular 5.
Okay, and then you're supposed to have something for the half also. So it should be, because it's a half, that's here. So vertically compressed by a factor of 2.
Okay, so I have to write that.
Mhm.
Okay. Then count it out.
Yep.
It usually so loud, but it really. I mean, like, that's code. No. No, no. And you're really proud of me. Like, that's what it was in middle school street. So you're good. Okay.
Okay, so when you're ready for the answer, take a look.
It just looks like a grass.
Oh, I
forgot to do all the other ones. Where you seeing 1.5?
Yeah, 1/2 times 1 is 1/2 plus 1 is 1.5. What questions do you have?
I'm good. Wait, what do we have to? Oh, I forgot.
How do you do?
Damn, I forgot. We did that.
vertically compressed by a factor of 2?
Yeah, I didn't get to.
You got the Swiss sign on the birthday? You got the fact that you do the parentheses, then the exponent, then times in front? Okay, that's really it. Okay, work on your, worksheet, please.
Wait,
I need to do some.
Oh,
Why is everybody yelling? Sorry.